All right, and we're back. So our next section in our notes, we're skipping 7.2 momentarily. We'll come back to that in a little bit. But we're moving on to actually 7.3 is the next section that I have for you, which is logarithms. Okay, so we're going to learn about the basics of logarithms and know what a logarithmic function is going to be. So graphing out our logarithms as well. But before I even get started, I want to go through some rules with the exponents first, because that's what a logarithm is. So I even have the definition already over here. So if you guys want to jot that down already. So it says a logarithm is just going to be the exponent to which a specified base is raised to obtain a given value. So you're solving for the exponent. Okay, so it's really, you can honestly go from one way to the other. So we have exponential form. So written with the exponent, that's exponential form, saying b to the x equals a. And then you're just going from exponential into a logarithm. So this is the same exact problem, but now written as a logarithm. So it's log base b of a equals x. So if you notice where the exponent, with the exponent being x itself, it is equal to, again, log base b of a. So like I said, you're solving for the exponent. Okay, but before we get started with that, we'll come back to this in a little bit. But before we get started, let's go back. And like I said, I want to review some exponents with you. Okay, so things that we should definitely know. So I'm just going to do some kind of basic problems here. So if I do, let me just do like bases of 2. That'll be easy. So if I do like 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the first, and then 2 squared. Okay, let's start with the easier ones. I'll start with 2 squared. 2 squared is just simply 2 times 2, and that's 4. 2 to the first is obviously 2. 2 to the 0, anything to the 0 is just 1. But now 2 to the negative 1. 2 to the negative 1, again, you should know by looking at what it's going to be. But I just want to refresh you on negative exponents. So if you do have a negative exponent, to make it positive again, all you're going to do is take this and move it down to the bottom to make it 1 over 2 to the first, which would obviously just be 1/2. And then same thing with 2 to the negative 2. Make this positive, just move it down below to be 1 over 2 to the positive 2, which would just be 1/4 then. Okay, so if you know what 2 squared is, then you should know what 2 to the negative 2 is, because if 2 squared is 4, then 2 to the negative 2 is just going to be 1 over 4. Okay, but I also want you to take note, we've also learned back in chapter 6, we learned about rational exponents, which is basically an exponent that's going to be a fraction. So if I asked you what's 16 to the 1/2 power, okay, first thing you should be thinking of, well, a 1/2 power is the same thing as taking the square root of 16, which would obviously just be 4. But what if I asked you for 16 to the 1/4 power? Well, a 1/4 is taking the 4th root of 16. And if you type in 4th root of 16, you actually get 2. So keep in mind, we might also have rational exponents since we know what they are. But what if I did like 16, let's say, to the negative 1/2? Well, again, it's a negative exponent, so we got to make it positive. So it's 1 over 16 to the positive 1/2, which is 1 over the square root of 16, which would ultimately just be 1/4. Okay, so I just want to refresh this with you. Make sure you know your exponents, negative exponents, positive, rational. All right, anything to the 0 power. You should definitely know all these rules by now. So moving forward with today, our new lesson. All right, so again, if I have b to the x power equals a, so if I want to write that as a logarithm, the base of the exponential is also going to be the base of the logarithm. Okay, so the base goes down in the basement is usually what I always just say. B goes down the basement, base goes down the basement, and the a and the x, they basically just kind of flip sides. So the a goes next to the logarithm, so after log base b, a goes next, and x again is the exponent that just goes on the opposite side. Okay, so base goes in the basement, just switch around a and x, and that's basically it. So how you read this again, this is read as being log base b of a, and that equals x. All right, so it says, and there's also obviously some stipulations here too when it comes to writing these. So b is going to be a positive value, just not 1, but a also has to be positive. Okay, the exponent itself, as far as x goes, the exponent could be a lot of different things, as we already just saw. So for our first examples, all we have to do in the directions, it says to write each equation in logarithmic form. So we're just going to practice going from one form to the other. We're going to write each one as a log. So for example 1, if it's 2 cubed equals 8, which is obviously a true statement, 2 cubed is 8. As a log, this would be log base 2. So then the base goes in the basement, and now 3 and 8 just switch sides. So it'll be log base 2 of 8 equals the exponent, which is 3. And that's your answer. Okay, but notice too that these are all on the same line. The 2 is just the subscript. So the 2 goes underneath, but everything else stays all aligned. What I always see students do, they want to do this. Log base 2 of 8 equals, and then 3 is kind of floating up on top because they see it as an exponent. But it actually should all be all in line with each other. Okay, so all going straight across in the same line, all in unison. All right, so for the next one, as a logarithm, so 3 squared is 9. Again, that's a true statement. But this would be log base 3 of 9, and that equals 2. This would be log base 8 of 1 over 64 equals negative 2. The next one, this would be log base 1/3 of 1/9, and this equals 2. This would be log base A of C, that equals B. This would be log base 25 of 5, this equals 1/2. Okay, so pretty easy, not too bad. Now we're going to do the opposite. We have the logarithm, now we have to write it exponentially, which I think is a little bit more fun. And just kind of do this little swooping motion, if you will. So again, the base of the logarithm, which is 3, it is being raised to this power, and it's equal to this amount. So 3 to the 5th power is 243, and that should be a true statement. Okay, so if you kind of mix it up accidentally, let's just say you accidentally put 5 cubed equals 243. Well, that's not a true statement. 5 cubed is 125. It's not 243. Okay, so just to make sure you did it right, again, 3 to the 5th power should equal this. All right, so that's one way you could always check it too. But just kind of swoops around. So number 8, same thing, starting with the base of the log. 4 cubed is 64. So 4 to the 3rd equals 64. There's the exponential. 8 to the 1/3 is 2. Again, that's a true statement. 8 to the 1/3 is 2. The next one, 9 to the 1st power is 9. That's obviously true. Then we have 3 to the negative 3, and that's going to be 1 over 27, and then b to the 0 equals 1. And that's it. Okay, so just knowing how to go from one form to the other, and that's basically it so far. Okay, there's a few special properties down here, as you can see. So it says log base b of b is 1. All right, so if these are both the same, basically it's going to be equal to 1. Or if log base b of 1, that's always going to be 0. So if you have log base b of 1, of some value of 1, then that's just always going to be 0. There's a couple more examples as you see. Okay, because here's what they are exponentially. If I have log base b of b, that equals 1 because as an exponent, this is just b to the 1st power, which is obviously going to be b. And then for the second one, this is just saying that b to the 0 power equals 1, because again, anything to the 0 power is just going to be 1. So just kind of ones that you should probably get used to and start recognizing right away. Okay, but on to the next side, it says we have this thing called a common log, which is base 10. So it says a logarithm with a base 10 is called a common logarithm. If no base is written for the logarithm, the base is assumed to just be 10. So you can write it, if you have a base 10 log, you can write it as log base 10 of 5, or you don't even have to write the base 10. You could just simply say log 5, and we automatically assume that it is log base 10 5. Okay? So if you have 10 cubed equals 1,000, if you had to write that as a log, you could write it as log base 10 of 1,000, and this equals 3, or you could just simply say log 1,000 equals 3. So you don't have to write the base 10. Okay, this is only for base 10 logs too. So for example 14, it says to write log 0.1 equals -1, write that exponentially. So there's an invisible 10 here. So if I had to write this exponentially, just kind of swooping it around, I would say that 10 to the -1 equals 0.1. Okay? So now that we know that, here's the harder part of today. Okay, it says to evaluate each expression by using mental math. So we are evaluating these logarithms. Okay, so if I asked you what is log base 5 of 25, you gotta know what it is. So what you're really asking yourself, okay, again, when you're solving a logarithm, when you're evaluating it, you're solving for the exponent. So what I'm really asking myself for 15, if I want to find log base 5 of 25, I'm asking myself 5 to what power is 25? That's the question. You're solving for the exponent. Okay, so 5 to what power is 25? That should be pretty easy. We all know that's 2. 5 squared is 25. So it gets a little bit tougher though. So on to the next one. Again, if I asked you what's log base 9 of 3, you're asking yourself this. 9 to what power is 3? That's the question. 9 to what power is going to give me 3? Well, we know the square root of 9 is 3, right? And what's a square root as an exponent? Well, it'd be to the 1/2. The 1/2 power. 9 to the 1/2 power is 3. So this is what I'm talking about. You have to know how exponents work. Okay? For the next one, number 17. What's log 1000? Well, the question is this, right? 10 to what power is 1000 is the question. So if you don't see the base, you just assume it to be 10. So 10 to what power is going to be 1000? Hopefully that one's not too bad. That would just be 3. 10 cubed. So the next one, 18. Question is 125 to what power is going to be 5? So it's a lot smaller. So let's see. So if you kind of play around with some numbers a little bit, we know that 5 to the first is 5. We know that 5 squared is 25. We know 5 cubed is 125. So what's the relationship? So how do I go from a 125 though back to a 5? We're going to do the opposite. It'd be to the 1/3 power. So if 5 cubed is 125, if you take the cubic root of 125, which is a 1/3 power, then you'll get 5. Okay? For 19, question is 4 to what power is 1 over 64? That's our question. So again, playing around with some exponents. I mean, they're not going to be too big, as you can see so far. We got 2, 1/2, 3, 1/3. So it's going to stay within a certain range. But again, if you know 4 to the first, we'll start basic. 4 squared. We should know 4 cubed by now. That is 64. But I want 1 over 64. So how do I get that? A negative exponent. -3. If you know 4 cubed again is 64, then 4 to the -3 is going to be 1 over 64. And same thing for the next one. Okay, our question is 5 to what power is 1 over 625? That's the question. So playing around with some exponents, we already did some on the other side. We left off with 5 cubed, so that's close. It's probably going to be the next one. So if you figure out what is 5 to the 4th, that is 625. So now how do we get a 1 over 625 though? It'd have to be -4 in this case. 5 to the -4 would be 1 over 625. So negative exponents again give you a fraction. If you're starting off with a small number as your base or a big number as your base, and you're getting a smaller number in the end, it's just going to be a rational exponent. It's going to be a fraction. Okay, so these are things, little tricks and stuff that you kind of have to pick up on. All right, so 21, the question is 8 to what power is 8 cubed? Well, that's kind of obvious. It has to be 3. 8 cubed is 8 cubed, right? And then for 22, 27 to what power is going to be 1/3? This one's a little bit trickier. Okay, so there is another way you can kind of work around these. So let me show you something else. All right, 27 and 1/3. Let's make these have a common base. So instead of 27 and instead of 1/3, let's manipulate this a little bit. I'm going to rewrite 27 to be 3 cubed. Because I know that 27 is the same thing as 3 cubed. So I'm not really changing the problem yet. Okay, I'm not changing anything. I'm just changing what it looks like right now. So instead of 27 to the x, now it's going to be 3 to the 3x. And that's equal to 1/3 is the same thing as 3 to the -1. Okay, so once you have the same base on both sides, like we do here now, the same base being 3, what you could do now is just set the exponents equal. I'm just going to set 3x equal to -1. And if I solve for x, I get my answer right there, -1/3. Okay, so that's another way you can kind of work around the problem as well. All right, 23 for this one, log of 0.01. So that question is 10 to what power is 0.01? I'm going to change that to a fraction. So what is 0.01? Well, how you read that, it's 1/100th. So again, I know that 10 squared is 100. So if I want 1 over 100, I need a negative exponent, negative 2. So log of 0.01 would be negative 2. Okay, so these just honestly take practice. It's something new, something you've never done before. You just need to practice these and you'll get better and better at your exponents. Okay, I promise you that. Just practice, do your homework, stay on top of it, and you will be pros at this in no time. So the last thing we have to do, it says now we're going to be graphing a log function. Okay, use the x values, it says graph the function and its inverse. So we're going to graph the exponential first. So this is what we did last section. We have this exponential function, y equals 1.25 raised the x. So all we have to do is plug in these numbers for x that they already selected for us, negative 2, 0, 2, 4, 6. Plug them in, solving for the y. Thankfully, I already did that for us. So when you plug in negative 2 for x, so 1.25 raised the negative 2, it's about 0.64. 1.25 to the 0 is obviously just 1. And then 1.25 squared is about 1.6. 1.25 to the fourth is about 2.4. 1.25 raised to 6 is about 3.8. So let's graph out this exponential first, and then we'll continue on with the last part. Okay, so if I graph this, I'm going back 2, and then going up about 0.64, and then 0, 1 is right here. That's my y-intercept. And then going forward 2, going up about 1.6, and then going over 1, 2, 3, 4, going up 1, 2.4, it's about right there. 1, 2, 3, 4, 5, 6, and then going up 1, 2, 3.8. Okay, so here is our exponential. Again, it levels off just above the x-axis. I'm going to label this f of x. Okay, so let's jump down to, we're going to do the domain and range to the function. So this is our original function, f of x. The domain, again, is always going to be all real numbers. The range is going to be strictly positive. If you look at all your y coordinates here, they're all positive values, right? So my y's are just going to be greater than 0, or you could just say 0 to infinity. Okay, I'm going to do now the second part. I'll do this in a different color. Now, okay, what we learned too, back over here previously, or did we learn this? I guess I didn't talk about it. Well, anyways, what it comes down to is that a logarithm and an exponential function, they're basically just inverses of each other. Okay, so if you can do the exponential, you could definitely do the logarithmic function. So if you remember what an inverse is though, so this was a few chapters ago, what an inverse is basically taking the x's and y's and you just switch them around. Okay, so since we're just getting into logarithms, all right, we're just getting into the basic stuff here. All I'm going to do again, it does say inverse already, so the inverse function is just going to be log base 1.25 of x. So if I switch around all these values, my x's and y's, now it's going to be 0.64, negative 2, and then 1, 0, and 1.62, and then 2.44, and then 3.86. Okay, again, once we get more and more into logarithms, we'll see exactly how they end up being inverses. But I want to show you how this works graphically. So as we plot these points, so I want to go forward 0.64, but then down 2. So there's that point, and then 1, 0 is right here. 1.6 going up 2, out there, and then going 1, 2.4, going up 1, 2, 3, 4. And then we got 1, 2, 3.8, going up 1, 2, 3, 4, 5, 6. Okay, so here's how this one works. It's just the opposite. So as you see it going this direction, it's going to be slowly getting closer to the y-axis this time, but it's never going to cross it or touch it. So again, it's going to do just the opposite as the exponential function did, okay? Because it's going to be its inverse. So it's just taking that function and then just flipping around basically all the characteristics that we know from an exponential. So if I had to identify the domain and range of our logarithmic function, we just want to switch around the domain and range, basically. So if my range was 0 to infinity, well, that's now going to be the domain of my inverse function, my logarithmic function. So this would be from 0 to infinity. And then as far as my range goes, well, my y's will continue forever and ever. It's all real numbers. Okay? And something else I want you to take note of is when it comes to inverses, they're always going to be reflections, if you recall, over the identity y equals x. So every single time you have an inverse, maybe I should label this one too, that's the inverse function. Every single time you do an inverse of anything, it's always going to be a reflection over the line y equals x. Okay, and you can actually visually see that reflection. If you were to take that blue line and just flip it over y equals x, we see that reflection. All right, so pretty neat. Okay, we'll be doing more of these too throughout the year. But that's it for this section. There's logarithms. All right, let us know if you have any questions and have a great day.